Here. All right, so welcome back, everyone. Today we'll have lesson 3 for Technical Features, and we'll be going over a lot of topics today. So first off, we're going to go over this topic on complexity analysis, and then second, we'll go over coding principles. This will be a short review on what is considered good code, since that's important both for software engineering and interviews. And third, we'll also kind of go over the strategy or approaches for taking on technical questions. And then lastly, we'll go on this topic of arrays. And this will be a part 1 of 2 series. So the next lesson is also going to pick up the remainder of this arrays topic. And just a heads up, since this will be covering a lot of topics, apologies in advance if I don't get to the arrays by the end of today's lesson. But hopefully this will also get picked up by next lesson. So yeah, let's get started. All right. So yep, this is the topic for today. So time and space complexity. So yeah, so why are we going over this? There are kind of 2 reasons here. This is also asked in most algorithm and data structure questions. Your interviewer will ask you probably toward the end after you write your code or as you kind of explain your approach to the problem about what you think the time and space complexity of this question is. And the reason why they ask you this is because they want to make sure you know the foundational computer science knowledge. This is also something that you also need to know to write efficient code, which is important for running applications on large scales. And this is why this is also a requirement in passing technical rounds. So what are they? Time and space complexity. They sound pretty complex, right? Well, so let's take it one by one and understand what each of them are. So first, time complexity. So time complexity measures the amount of time taken by an algorithm to run as a function of the length of the input. So that also sounds like a pretty hard explanation, but to make the story short, basically measures how fast your code runs in relation to the size of your input. And that's also a similar story with space complexity. Space complexity measures the amount of space or memory taken by an algorithm to run as a function of the length of the input. So once again, this is also similar to time complexity, but instead of measuring the time that it takes, this measures the amount of space or memory. When people talk about memory, they usually talk about how much RAM it takes to run. So that's what it means. So yeah, well, now that we have gone over the definition, let's kind of go over some of the sample problems. So this is, so suppose you're given an array A and an integer X, and you had to find if X exists in a given array. Right, this is a pretty simple problem. So imagine you have an array A with maybe 10 integers or something, and I would like to ask you, hey, can you find this integer X if this integer X exists in this array? Can anyone take a shot at how you would go about doing this?
You just iterate through the array until you find X.
Yep, that's a pretty simple approach, right? So as you said, this is how the code might look like. This is all written in Python, but you could also kind of treat this as pseudocode. So not too much worries on the syntax part. So here you're kind of iterating the array. So it's called I in array, and you're checking if that I, the value I is equal to X. And if so, return true. And if not, just return false at the end. Right. So it's pretty simple solution, but now I'll like to ask you, hey, what do you think the time complexity of this is? Right. So this is the kind of problem that we'll be going over today. So in order to describe the time and space complexity, you need to know this concept called order of growth. And so this describes how the time execution depends on the length of the input. So there are 3 main notations here. The one that we care the most about is the one that's highlighted here, which is the big O notation. And this describes basically the asymptotic upper bound, or basically the max amount of time that your code could take to run. And in computer science, there are also other 2 similar notations. One is called big omega notation that describes the lower bound, And then lastly, there's also big data notation that describes like the type bound, which basically is limited by the upper and the lower bound together. But here in most of the technical interviews, what you care about is the bigger notations. And because this kind of gives you the upper bound or the limit, right? So yeah, this is what we care about. You might see this with like this notation or just like a big O, capital letter. So how do you calculate it? Well, first, let's just kind of focus on the math part before we get to the computer science part. What you do is you like ignore the lower order terms, since the lower order terms are relatively insignificant for large input, right? So, for example, like let's say if you have a function that has like something a little crazy, like 2 times n squared plus like 3 times n plus 5. And now you kind of want to like let's say take the big O notation of it. So you wrap this like function of n, n being like the size of input around this like O function. Then what do you get out in the end? Well, what you do is like you start ignoring the low order terms here. So the highest order term here is this n squared. And then, so from here, you can kind of drop the constant, which is 5. So you can kind of ignore this. You can also ignore 3 times n, since n is a low order term. Right? This is like more like it's implicit, this is n to the first power. So you can also ignore this and drop it. And now you're left with like 2 times n squared. Oh, sorry, my audio just got switched over. But and then you can also kind of drop this like 2 times, this like 2 part, because this is like multiplying the n squared part with a constant 2. So you can also drop that. And in the end, what you're left with is like this like O of n squared as your big O notation. And this is a cheat sheet. This graph shows like how that basically like time complexity grows along with the size of input, and also with like different efficiency. So let's say in the base case, like we're looking at O of n, right? Basically takes like this means like your code runs like linearly. So as your size of input grows, your runtime is also going to grow like linearly alongside with it. So you see this like kind of like a increasing line over here. And on the other hand, you also have like this like O1, which is like this like that would apply for like a constant time lookup. So like let's say accessing an element within an array will be O1 because you're basically like specifying, hey, at what address in the memory you're getting that value from when you're accessing the value from an array. So that's a constant time lookup. And then there's also a bunch of like other terms here, right? This just kind of like lists all the most common one here, but there's also like log of n and n log n that you might see from different places. N log n is technically one of the most like efficient runtime that you could apply for sorting. There's like a little caveat there because there are tricks that you can do to get down to O of n if certain conditions are met. But things like merge sort, you can run in n log n, and that's faster than like running a bubble sort, which would be n squared, right? This means that your runtime is going to run exponentially compared to your size of input. And there are also a bunch of like crazier ones, like 2 to the n's and like and polynomial, n factorial, which means your runtime is going to be very, very slow there, right? So yeah, so the reason why I'm describing this is your algorithms or your operations is always going to have this kind of runtime. So it's important that you know about, hey, what those operation or what those algorithms is going to cost in terms of like time complexity. And here is also a table showing you the runtime of each of these data structure operations. So you might already have an intuition for how that might work for array. So as I said, accessing a value within an array will be O of 1. Searching will be O of n, because as we kind of like wrote in the code back there, you have to iterate through each element. And if the size of the input is n, that's also going to take you O of n time. And insertion deletion, that's also going to take you O of n at the worst case scenario, since you could imagine, hey, if you're actually managing the underlying memory and you already like reached the size of the limit of the size, you would need to double it, right? Or you need to increase that memory. And that operation itself could cost O of n before you could actually insert like a new item into the array. So yeah, this is just an example, but yeah, feel free to go through this. This is going to be probably helpful to just really like kind of almost like memorize and understand how those operations cost. Because as you write code, you inevitably like do some of these operations. So you have to know, hey, how those operations like add up to your total runtime. Let's see, any questions? Looks like Horatio, you have a hands up.
Yeah, I had a question for the for time complexity. Should we always just mention the worst case scenario? Is that what is expected?
Yeah, pretty much.
Okay.
Yeah, that's what the big O notation also stands for. It just like stands for like the upper bound, which also means like the worst case scenario.
Oh, okay. Sounds good. Thank you.
Yep. All right. So, yep. So this isn't okay. So let's go through sample problems again. So here, this function, we're just getting us input of n, which is the array of n size, and we're just getting a count of how many values they are, right? And nothing significant about this code, but just to kind of go understand how the time complexity work. But does anyone know how long it would take to run this code?
All of them.
Oh, sorry.
Yep, Maria, that's right. It's O of n. It's not a trick question, right? And it takes O of n because, as you can see, the count is incremented for each number from 0 up to n, right? So we're counting n times, and that's why it takes O of n. All right, problem 2. It's a little more advanced this time. Now we have, instead of a single loop, we have a nested loop, and we're also counting how many times we're basically going through this loop. But does anyone know what the runtime of this would be?
N squared.
N squared, right? That's right. And then to kind of explain the reasoning why, here we're counting and like n times inside this inner loop, right? And then we're doing those counting also n times through this like outer loop. So we're basically doing like n times n, which ends up it's like n squared. And so yeah, that's how the runtime is going to be. All right, last sample problem. This is a little tricky. It's the same as the last question, except this part, instead of range n, it just ends. It just like ends at I, and this I is basically the index that's determined by this outer loop.
Is that n log n?
Okay, that's a good guess. Do you want to try to explain why
n
that might be
squared.
n log n? Okay, well, somebody else said n squared. Eduardo, was that you?
Yeah, I said n squared.
Okay. Do you want to explain why then? Why this might be n squared?
Because I think I is going from 0 to n minus 1, and then j is going from 0 to I. So I guess it's also going to n minus 1 also. So I just kind of saw it as like going from basically n. Yeah, I saw it as going from roughly the same kind of range. I don't know if that's a decent explanation.
I see.
But doesn't it so when I is 1, it goes 1. Then when it's 2, it goes 1, 2, right? And
Right.
So it's
Oh, sure.
it's iterating more than n than I in range n. I don't know if that makes sense.
Yeah. No, I think both of you guys have like the right intuition. Horatio, you're on the on the other side of the spectrum, saying that yeah, because this I figure is going to be small, right, as you start out. Like for example, like during the first iteration of this outer loop, this I value is going to be 0. So this inner loop is it's technically not going to run at all. And in the next loop, this I value is going to be I. So in that second like iteration, this like inner loops iteration is going to only go from like 0 to 1. And you think because that's like not going through the full loop, that's going to be more efficient, right? I think that's your intuition, Horatio. Whereas Eduardo, I think you on the other side of the spectrum, thinking that hey, even if it's like only going through like those like few numbers in the beginning, in overall it doesn't matter because it seems like it's going to add up to like it's going to be like rounded up to like O of n.
Yeah.
Right. So yeah, I mean, both of you guys have like the right intuition, and this is actually pretty tricky, and actually answer is O of n squared. So as I explained, kind of explained the mechanics about how this like iteration will work, and how this like inner loops iteration is going to be smaller toward like the first like toward the first like few iterations of this outer loop. But mathematically speaking, so this can be expressed as like, okay, the inner loop is going to basically do like, counting of 0 times in the first like iteration of this outer loop. It's going to count 1 time in the second iteration outer loop, and it's going to count second time for like the third iteration of like outer loop and so on, until we get to like n-1, right? But when you do this like 0 plus 1 plus 2 plus ... all the way to like n-1, that also means like, okay, they are n over 2 terms of the value n-1. And this is because like, hey, you can imagine like adding the first value and the last value of this series together, and the second value of like the second and last value terms together, and they'll always like end up equal to n-1. And because we're using 2 terms to like get to this like n-1 value, there are total of like n over 2 terms or number of values that equals to this. So that means, okay, now that we have that, we can multiply by n over squared, n over 2 times like n-1, which what's going to end up with like this like n squared divided by 2 minus like n divided by 2, right? And remember what I said about, hey, ignoring like lower terms and everything, right? So once we end up with this like expression and we wrap it with like the big O notation, what ends up happening is, well, we could ignore this like term, the low order term n over 2, because this is the low order term compared to like n squared. So we're like really focusing on n squared over 2. But even this over 2 part or divided by 2 part, you could also kind of like re-express as like 1/2 times like n squared, and any kind of like constant that's getting multiplied with this like high order term, you could also ignore it too. So in the end, you also end up with like like n squared. So yeah, I mean, both Horatio and Eduardo, like you guys have like had the right intuition. But sometimes this is just kind of show you how sometimes it's like can't really trust your intuition unless like you write it out in like mathematical expression and see how that ends up. And that's kind of like interesting like structural loop where the upper bound of inner loop is set by the inner the upper bound of this inner loop is set by the outer bound of the outer loop index. You're gonna probably see this in different settings as well. So just remember, hey, this is gonna actually end up with like O of n squared. Horatio, you had a question?
Oh, my hand's still up.
Yeah.
But,
never mind.
yeah, so basically it's n squared because when eventually I will be n. And so because I will be n, it's 2 n's, and then it will be n squared.
I would say that's the right first intuition, but then I'll say, hey, like you wouldn't really know unless like you kind of like write this out in the mathematical format and see how this expression ends up.
Okay.
Yep. But yeah, does anyone have a question on this? Does this make sense, or was this too complicated? Because if so, I'm happy to go over this again. So
Or you're cutting off a little bit.
cutting off. Sorry, I'm cutting off.
Now I hear you better.
Okay. Let's see. No question? Not, we'll just move on. All right. So now moving on to the next topic of coding principles. So while we're going over this, this person, Guido, who created this Python language, said, code is actually read much more often than it is written. And that is probably the most true thing that I have learned over the course of my short career in software engineering, which is even like the shortest code that you write is going to get read by so many other people within your team over the long period of time that the code is going to stay in the repository. So that's why it's like important to kind of like follow the good coding principles to make your code easy to follow and maintain. And so this is like important things to know anyway for your software engineering career. But even within interviews, coding styles can also be a part of evaluation, right? You can imagine even if you write like a really, I guess like correct solution, but you see, but you end up like declaring variables with like bad naming, and your code is like also like not formatted correctly. The interviewer is gonna like raise their eyebrows and think, like this person got the correct answer, but can this be repeated with like other problems, or do I really want this person to write my code, write our team's code, right? So that's why it's like really important to know these coding principles. So what is actually considered good coding or good code? I mean, with anything, this is pretty subjective, but there are like 5 main aspects of good code, according to this book, Cracking the Coding Interview, by Gail Lachman-McDowell. Sorry, if I'm like mispronouncing her name, but and this also kind of this is also stands true for any kind of coding languages, or if you ask like any of the software engineers out there. So to quickly go over those 5 main aspects. Good code is correct, which means it handles both valid and invalid input and returns the expected output. Good code is also efficient, which means the code operates efficiently with regards to time and space. And good code is also simple, which is written as simply as possible. Basically means like less code, the better. And good code is also readable, which means the code allows other developers to easily follow. And lastly, good code is maintainable, which is that the code allows other developers to easily modify and extend. And to dig deeper into each of these things or aspects, so you might ask, hey, how do I make my code correct, right? So here are the tips that we'll have for you, which is you want to think about different cases and how your code can handle them. So example question that might be going through your head could be, hey, you could be asking yourself, can my code handle invalid input? Invalid input for like, for a lot of things could be things like, an empty data or empty string, or it could also basically have like a invalid character, right? So those kind of things. You could also ask yourself, can my code handle input with different data type? So if you know that you're getting an array, but can that array get other types of data types, such as like string, integer, float, like all in that one data? But if so, you may need to also update your code to handle them differently. And you may also ask yourself, hey, what happens if my input has the multiple same values, right? If it has duplicates, or if it has the same value, but they mean it's a different thing. For example, like you could imagine there are multiple Michael Jordans in the world. One's a famous basketball player, and the other ones not so, but they also exist in this world, and we may want to also have a different way to differentiate them. Right. So those are the kind of questions that you might ask yourself to to make sure your code is could actually run correctly. And then lastly, what do? You also write tests to gain confidence that your code is correct, right? So when you write tests, you also want to throw like a different types of scenarios at it to make sure that it is still returning the expected answer. All right, and then next, moving on, like how do I make my code efficient? So here you want to think about different things here. But first, you could think about introducing a helper data structure that could make your code run faster. Here you're making like explicit trade-off between space and time. So which means that you're introducing more space or more memory, but then you're reducing but with those like helper data structure, you're also reducing the runtime. So things here that could help you, things like hash map, set, trees, right? So for example, if you get your input and store them in these like helper data structure, like hash map, you're introducing more memory, so you're making it less efficient from the memory perspective. But now, like let's say if you're like the rest of your code like requires you to like look up the value, now you look up instead of like when like against this array. If you have a hash map, you could do that in constant time, and that's much faster, right? So you could be making these kind of space-time trade-offs, and that's important to kind of like note and fall back on if you could actually do that. For some other problems, you may not be able to do it. For example, like they're not allowed to like introduce memory, or that may not be possible if like the data size is like too big, and you kind of like overflow your memory, right? So even in those cases, you have like algorithms or techniques that could help you. So some of the things that could help you here is like pre-processing. Sometimes like you could pre-process your input. For example, you could sort them up front, or you could basically like, let's say, drop some values depending on whatever problems you're working on to kind of make your input smaller or like easier to work with. And that could basically help with the rest of your code's like runtime. For example, even doing like this search problem, as we kind of said, if we're looking for a value, right, that was like O of n, because we have to iterate through each element in the array. But if let's say if the array has been already giving you pre-sorted, you could actually do this in like log of n time, and log of n is faster than O of n, right? And you could like get to that faster time by doing a binary search, which means you basically kind of get to the middle element, see if that's like bigger or smaller than the element that you're looking for, and depending on whichever direction, you basically go to that other half of the array and you keep that process until you find that element that you're looking for, or you don't find it and you say, hey, there's no element that I'm looking for in this array, right? So these kind of algorithms and techniques that you could use for sorting. Merge sort basically is famously known to use divide and conquer, right? So there are these kind of things that you should learn over time. That's going to help your code like run faster. And this doesn't really get asked in interviews, but it's also good to know for like real life applications. But you could also think about making your code multi-threaded or multi-process for IO bound and CPU bound operations respectively, right? So what I mean by that is for like an IO bound, which means your operation or your program is limited by the slowness in the input and output operation, you could make your code multi-threaded. So for example, here for API calls and network calls, you can make your code multi-threaded to basically like run multiple calls at the same time. And the reason for that is when you make these like IO bound operation, there's a lot of delay. So it's like basically like time in which your computer is not doing, just waiting for that response to come back, right? But instead of like wasting time just waiting around and doing nothing, you can basically like make your computer like do multiple of these things at the same time, so that you could you don't waste, your computer is not wasting time just waiting around, but making additional requests and then handling it as those requests come back. So yeah, this is like a kind of pattern that you may see often with API calls and network calls. For large volume data operations, for example, like you could imagine for companies like Google, like they do tons of data operation against like large data size, right? And it's almost impossible to do or like finish it in like a feasible amount of time if they just run in one computer. So what they do is they will make it multi-process, which is they'll basically set up a bunch of computers, like hundreds, not thousands of computers, to do large volume data operations, to run those operations in parallel. So you could imagine, even for like a simple operations like multiplying every number in the array by 2, if that array has like a size of 10 billions, man, that's going to take a long time to run it if you were just running on your laptop. But let's say you have like 10 of those laptops and you decide that, hey, each one's going to just take on 1 billion instead of like 10 billion by yourself. Then actually your program is going to theoretically run 10 times faster just because you have like 10 times more the resource. So that's like one example. Another thing that you should also know about multiprocessing is that modern CPUs, so modern computers, also have like multiple cores within the one CPU set. So I'm sure like if you have like some kind of laptop, a lot of them are just like either like dual core or quad core. You may have like heard this term when you're buying a laptop. That actually means that your CPU set actually have like 2 CPUs, so 4 cores or 4 CPU cores. If it says quad core, so you could actually make your single computer multi-process as you kind of split up the workload between those CPU core. So rule of thumbs here is, well, when you're going through an interview or even when you're writing code within real life, hey, just ask yourself, if you're using nested loops, so multiple iterations of the same loop, think if there's a way to make it more efficient. Especially if you're going to nested loop, maybe there are ways you can make it more efficient by using helper data structure that would make allow you to just cut it down to like single loop. Or maybe there are some other techniques that you could use that would help you to reduce it. So just know, hey, whenever you're writing nested loops or whenever you're like iterating through the same loop like multiple times, maybe there's like something better that you could be doing here. So I mean, just a heads up, it turns out that there may not be a way to make it more efficient, but it's usually a good rule and a good possibility there is one. So any questions about this?
Yeah, I had I had one question.
Yep.
So like, let's say on an interview you were like, you know what, for whatever this problem is, I'm going to use a binary search tree or a binary tree, right? Is it, I guess, like, to actually use that, is it that you would use like a library that lets you quickly like use a binary search tree, or how would that like actually work? I'm just curious, because in my class we've only looked at like actually implementing them, not like just pulling them from a library.
Right. So I would think there are kind of like multiple ways in which like an interview round could pan out. I think nowadays it's rare that your interviewer would ask you to like implement some kind of data structure from scratch. But it is possible, right? And then even if you're not asked, it'll still be probably helpful to know how the inner fundamentals of the data structure work. So, for example, like building a tree data structure from scratch. It's a hard topic for sure, but may be helpful to just kind of go through the exercise yourself to just understand. But so yeah, I mean, there's that one scenario in which like your interviewer might ask you to implement a data structure, although that is unlikely. The second scenario is, as you said, you may be already given a data structure upfront. Like you may be given data in this kind of like a tree format, but then you could use the languages library to kind of like navigate around those data structure, or maybe like just directly turn whatever like raw input that you got into this like other like advanced data structure using the built-in library. So that is definitely possible. And with things like binary search, I'm sure like a lot of like languages, I know for sure in Python, there's like a library, like a built-in library that you could do to basically like do this binary search without writing one yourself, right? So there's also that way of doing things. And lastly, there's also a possibility in which, you may actually have to like implement the binary search yourself just to demonstrate that you actually know, right? So, I mean, there are like multiple spectrum here. Some are more likely to happen than others. So my tips would be that, I mean, you should probably like become familiar with like these data structures and algorithms, and know about these like language, the libraries that are available with your coding language. And yeah, and be ready, if they actually ask you to implement a data structure or algorithm. If that ends up being the case, I think that the focus of the question or interview round is going to be just on that. I think it's almost impossible that you expect you to like implement something in order to answer something else within like this like constraint of like 40-50 minutes that you have with your interview round. But each one of those aspects could become the main focus of your interview, and you should know about them. Does that make sense?
Yeah, thanks a lot.
Yep. Any other questions? Okay, let's see. Gonna move on. Oh, sorry.
question.
Go ahead.
Yeah, for the multi-threaded multi-process file bound CPU bound, we have to do that like during the interview?
I would say for entry level engineers interview, this is unlikely. Unless like maybe you're like interviewing for like a very like close in machine like like software
okay.
team. Yeah, this might
Okay,
become a
makes
part of the
sense.
question, right?
Yeah,
But your
okay.
interview might ask you, hey, how can you make your program faster? There's like, let's say, millions or if not billions of like data point, right? This is just like a kind of like answer that you should have, you should probably think about.
Yeah.
There are these basically like tool set that are available in real life, and there are these things that you could do to make it faster.
Okay, thank you.
All right. Any questions? Not, I'm gonna move on. So yeah, so just a reminder, went over how do you make your code correct, and just went over how do you make your code efficient. The third aspect is how do you make your code simple. So there are a lot of like different techniques that you could use, but kind of like one main tip that I would like to give you here is like you want to follow the single responsibility principle. It's also known as like SRS for short. And what this means, this definition I just borrowed straight from Wikipedia, which means like, yeah, you want to make every module, class, or function to have basically have a single responsibility, right? It's basically what the name suggests. So when you're kind of like first like starting out coding, you may have this habit of like just like putting everything into this one gigantic function. You may not actually call it just like do everything, but you can imagine, hey, you might have a function that does everything from start to finish. In this example workflow, like you may be downloading the data, and you may be then converting it, and you're finally exporting it, right? But then how you want to like actually organize this code is you want to kind of split them up into like a little function that actually does like single thing well. So you might have a function called download data that just does that. Another function for converting data, and lastly, another function for just like exporting that data. So that way, it is very like easy to know what the function is doing. And this also makes it extensible, right? Like for example, today I might want to just export this data in a CSV format or spreadsheet format. But tomorrow there might be a new requirement that comes in that says I want to export this data in a let's say a PDF format. In which case, you wouldn't have to like just rewrite everything in this like do everything function, but just focusing on updating this export data function. So this is why you want to make your code as simple as possible and try to follow the single responsibility principle. It's a pretty simple advice, no pun intended. Fourth aspect of making good code, you want to make your code readable. So like a main advice for this is that you want to follow your programming language coding convention. If you didn't know that your programming language coding had a coding convention, you should probably look it up. Either there'll be an official one, or there might be some recommended one that the programming community or the language community has come up with over time. So an example of Python, there's a famous document called PEP8 that establishes the official guide. And yeah, I mean, if that's interesting, you should definitely go over this talk. It's like one of the writers. So this is actually this Python creator, Guido, that I previously mentioned. But just to kind of go over one example, one important aspect of making the code readable is doing the naming, like a variable naming, right? So, well, it's not just variable actually, like just any kind of naming, right? So there's actually a naming convention in Python that you should be following according to this guideline. So for example, for function names, variable names, and module names, you want to be doing lowercase or lowercase with underscores that look like this. This can also sometimes be called as like a snake case, because I guess if you have a lot of underscore, it may look like a snake. I think that's why it comes from. I'm not sure. But yeah, example here is that, yeah, if you have a function called find oldest person, this is like how you want to be kind of like declaring it with like underscores. But once it comes to classes, you want to be doing cap words, which basically use capital letters for each of the start of the word. So in this example, if I have a class called classroom, I had the letter C and the R capitalized because they're the beginning of each word. And lastly, if you have constants, you want to be using uppercase, so uppercase with underscores. So let's say if I want to declare a constant that sets a max capacity of 100, I'll be using all capitalized letter to declare that. So yeah, make sure that you know about these like coding convention for your programming language, and then you want to follow this like as closely as possible. There are some exceptions where if you're like contributing to an existing project, and for some reason that project deters away from the official guide, and they have their own set of guidelines, then you may want to just follow that instead. But otherwise, you're like starting a project from scratch, or you're doing an interview. Yeah, this is the guideline that you should be following. And lastly, how do I make my code maintainable? So here, you want to make your code modular and organized. So this also kind of pertains to the single responsibility principle that I mentioned, but you want to write simple functions that can be used for multiple use cases. And other tips include organizing function with similar use cases as modules. Sorry, I have a double phrases here, but yeah, and then you also want to use classes to organize data and methods that can be associated together. So for example, using this example of like a classroom class, right? The data that could be associated could be like, students in the room, right? And you could imagine a bunch of like methods that could come up with regards to the students in that classroom. For example, a teacher is like managing that. They might want to know things like the average grade of this class, or they may want to know like the size of this class and so on. And they're like, all these methods that you could start associating with this classroom class to kind of like make your code organized and basically have all those associated things wrapped in this one thing. And lastly, this is kind of like similar to organizing your room, but you also want to organize files in consistent directory structures or namespaces. All right, so we just finished going over the coding principles. So any questions? Any questions so far?
Someone had a question regarding the topic before.
Yeah.
Said, should they avoid using recursion?
Should we avoid using recursion in a code? Not necessarily. I think there are certain questions in which you would need to use recursion to get to the answer. For example, like if you're asked to do like merge sort, you'll probably need to use recursion. And then there are also like other classes of problems like in dynamic programming, you could be also be forced to use recursion. You want to get to the answer, since that would actually be the easiest way to do it. So yeah, this is definitely yeah, I would just say this is something that's possible. Like yeah, recursion is a possible thing that you may need to do in your code. Yeah, and if you feel like you're not good at recursion yet, just don't worry about it. We'll have also a lesson on recursion. So hopefully that's also going to get you become more familiar with it and get you started in more practices. All right, any other questions? All right, if not, gonna move on to the technical question approach. So the motivation here is kind of like twofolded. As everyone knows, solving technical questions can be a high pressure situation, especially when you're doing this in front of a person with like some kind of like a time constraint, right? But just to know, like, don't worry, that applies to like almost like everyone who's like doing the interview. But there's definitely a thing that you can do to kind of alleviate this kind of like high pressure situation, which is you want to be following like a principled approach to technical questions so that you can like think and solve problems like more systematically. So this also comes from the book Cracking the Coding Interview, but there's also a 5-step approach to technical questions. This, like, if you haven't gotten the book Cracking the Coding Interview, it's a super helpful book that I will highly recommend getting it. There's actually a section called technical questions, in which I'm actually borrowing a lot of ideas, and it's probably that I would say is the most valuable section of the book. So Horatio, you actually asked this question in Slack in the coding question channel. So if anyone hasn't had a chance to read his question, I would definitely recommend reading it, because me and another member of the Mentor Network has posted answers that I would think will be helpful. But once again, to kind of get back to the slide, so there's 5-step approach to technical questions. Step 1 is that you want to be asking questions. And step 2 is that once you ask questions and you got clarified, you want to start thinking about designing an algorithm. And once you have a confidence that your algorithm could work in a efficient time and space manner, you want to start writing code, and that code could be just pseudocode to help you organize more of your thoughts. And lastly, once you write your pseudocode, then you may start filling in those pseudocodes with actual code. And once you did all that, you want to run your code, test it, and as you find mistakes, you want to fix them, right? So pretty simple, the 5-step approach. But to kind of dig into each one of these steps. So step 1, you want to be asking questions. So technical questions is actually often asked like very ambiguously. And interviewers often do this intentionally to see if you can ask good questions and narrow down the scope of solutions. So I'm sure like a lot of people have been asked this question to get into a program, which is like, okay, hey, how do you find all this person from this input? And I think the interviewers within our team kind of noticed that some people do ask questions, whereas some other people would like to just jump straight into solution, and that's totally fine. But the recommended practice here is to kind of ask questions, right? So for this like example question, what are some of the questions that you could be asking? Or you could be asking, hey, what is the data format and input? Is this array or is this hash map? You could also be asking, hey, can there be multiple people with the oldest age? And if so, do we want to find just that one oldest person or like all the oldest people, right? Because depending on how many you want to return, the data structure that you need is probably going to be different, as well as like some of your code. And lastly, you could also be asking, hey, can there be multiple people with the same name? If so, how should we differentiate people with the same name, right? You could imagine, hey, if, just going back to that Michael Jordan example, there are multiple Michael Jordans, how do you want to differentiate, right? And having that conversation with the interviewer could also shape how your solution will look like. So for example, like the interviewer say, oh, like, don't worry about it. for this case, just assume that there's only going to be one person for like each name, or they might just ask you, hey, yeah, also please like take it into consideration and try to come up with your own way to like distinguish like those people with the same name. In which case you might want to start like thinking about, hey, like generating some kind of like a random key or some kind of like, yeah, I guess like key to like start keeping track of those like same people, multiple people with the same names. Right, so once you ask questions and clarified those ambiguities, you want to start thinking about designing an algorithm here. So a couple tips here as well. First, you want to identify the brute force solution. And this is like so basically saying, if you don't care about time and space complexity, what's the simplest way that can give you the correct answer, right? So that way, like, yeah, you don't really kind of like think about optimization and just like focus yourself on like thinking about an algorithm that could get you the right answer. And I know this is like a pretty big jump for a lot of people at first, but it's gonna get better over time with practice. And once the brute force solution is identified, then you want to start thinking about why this solution is inefficient and what you can do to improve it. So once again, just going back to the tips that I was going over with you guys earlier, you have to start thinking about, can you make your code run faster with more memory / like helper data structure? So here you're kind of thinking about making that space-time trade-off. Or you might be thinking, hey, are there any algorithms or techniques that can help with this? And as I mentioned earlier, those techniques include things like pre-processing the input, doing things like binary search to make the search faster, or doing divide and conquer to like distribute the workload, and so on, right? And once you start like generating these ideas, you want to kind of cut down both like runtime as well as space, and then you want to identify efficient solution and check with the interviewer if the proposed approach sounds reasonable. And then if the interviewer says, yeah, that sounds great, you please start coding, then that's actually a good sign. If an interviewer says, well, like your solution may sound correct, but would it be able to handle like those other edge cases? Then you may also need to think about just handling those things. Or your interviewer said, yeah, well, your solution could work, but that's still not the most efficient. Then you might need to kind of like go back to the drawing board and start thinking about other things that could be helpful to you. All right, so once you started to kind of brainstorm those algorithm and start sharing that kind of thought process with your interviewer, you want to start writing code. And here, this is optional, but it could really help you to just like write pseudocode or even use comments to help organize thoughts. And we're here to do that. Just communicate to the interviewer that, yeah, you're going to write pseudocode or comments first and follow up with writing real code later. So to show you guys an example here, with like define the oldest person function, you could be writing things like, hey, okay, first I'm going to build a hash map with key value pair of person name and their age. And once I have that hash map, I'm going to iterate through the hash map and check that the person age is greater than the oldest seen so far. And if that's true, keep that person's name and update the oldest age, right? So this is just an example, but you could be writing these kind of comments to help organize your thoughts. And then lastly, once you do that, then you can start replacing or filling in those pseudocode or comments with real code, right? So you could actually see beneath those comments line, I'm actually implementing the solution in code over here, like building a hash map and then going through an iteration to find the oldest person in this hash map. And finally, once you've done that, you can like run your code, test it, and fix mistakes, right? So here you want to try running your code with test input. And if your code fails to run and compile, just don't panic. Oftentimes you may run into this issue just because you have a typo in your code, because oftentimes, you're rushing in to kind of write those code, right? So there's no surprise you have a typo in there. Even if your code fails to run and compile, just read the stack trace and error message to see what went wrong. your stack trace is really your friend here that tells you what's wrong, so that you can like focus on those parts and try to fix it immediately. And once you see your code running correctly, then you want to start thinking more about test cases that could test like different edge cases. They'll cover different cases from like what the previous test cases have covered, so that you can gain more confidence that your code will actually run correctly against like all those different cases. All right, so those are the 5 steps approach to technical questions. But any questions about this? No? All right, if not, I'm gonna spend probably just the next 10 minutes just trying to practice or trying to demonstrate how that 5-step approach is gonna work. So, but we're gonna do that with our introduction of our first technical topic, which is array. All right, so what is array, right? Sure, a lot of you guys have already worked with this in the past. Different coding languages. This might be also be known as like a list, but array and list are pretty much the same thing. But to go over the definition, array is basically a simple data structure that represents a collection of items. And if you actually want to understand this, how it works underneath the hood, the items are often stored in contiguous or neighboring block of memory, which means like the memories are allocated in the same place within the memory. And this also has like a kind of like a nice property of the array. So how you access this array is like, like let's say if you're given an array A of I, denotes like this should be, denotes like the I+1 object stored in an array. There's +1 here because, remember, computer science is often like 0 index based. So A of 0 will give you the first object. So I will give you like the I+1 object. So A of I will actually be not the first object, but the second object is stored in an array. Just a heads up, because oftentimes you may struggle early on in your computer science career to kind of switch back and forth between, like the number 1 base that we use in real life versus like the 0th index case that we use in computer science. So just a heads up on that. So while you're going over array, so array problems are basically the basics of technical interview questions. And they might often show up in like in the earlier rounds of technical interviews because they serve as like a simple check to see candidates' programming skills. So array operations. So we think these are the important operations about array that you should know of. It doesn't matter if you code in Python or not. Make sure you know how to do each of those things with array. So there are operation things like instantiating them, which is like a fancy word for creating them. So make sure you know how to create an array. Number 2 is get. How you kind of get value out of those array is also important. Number 3 is the insertion. This one actually has a nuance because depending on how you insert things, you may want to insert like a new value in the array in place, or you want to return like a completely new array with a new value in it. Or sometimes instead of like inserting a new item, you may want to like extend it with another array, or basically you want to combine 2 arrays together, right? So also understanding how you can do that is also important. And this also kind of applies to deleting too. Like you could also delete an item in place, or you could also return like a new array. And you also have to know, hey, how can you not only delete a single item, but also delete multiple ones? Oops. Number 5 is size. This is pretty important. So make sure you know how to get the size or the length of the array. Number 6. Yep.
For get, that is just search, right? We're just searching for it and then returning it.
Yeah, I mean, it's not even a search at this point. It's more about like, hey, how do you make sure you know how to fetch like an ith item.
Oh, like an index.
Array.
Okay.
Yeah.
Yeah.
Yep.
That's what you're saying.
Yep. And then number 6, the iterations. Make sure you know how to iterate or loop through the array. There are ways to do it with like for loop. You may also want to know how to do it with while loop. Depending on what programming language you work on, there are also like multiple ways of doing it. For example, with Python, like I guess the famous like reserved keyword is like using a range around the array to get the index or to get the value out of it. But there are also ways to kind of like wrap that array with this reserved keyword or enumerate. That's going to give you both the index and the value, right? So that you can like work with those values at the same time pretty easily. So understanding all those like ways to iterate through array is important. You should know about them. There are also like mathematical operations, things like getting the min, max, and sum of the array is also going to be helpful. Certain programming languages to make it easier for you. For example, with Python, min, max, sum already like reserved keywords that you could actually just call by wrapping it around the array. So number 8 is sort. Once again, some coding questions might ask you to implement sort yourself, but most of the time you could rely on using the built-in operator given by the coding language. And there are also ways to do sorting in place, which will basically sort whatever array that you were given, and that will basically change that input array like permanently. Or you want to sort it, but create a new array out of it so that you don't kind of change the original input that you were given, right? So also knowing those 2 different ways to do it, sort is important. Number 9 is slicing, which is basically saying, getting a subset array. So like, for example, if you want to get this like part of the array from like the 0th index to the 5th index, how would you go about doing that, right? And this is important. For example, you could imagine in binary search, so you kind of cut down your your search space by half each time. Then you need to start slicing the array to kind of like narrow down your search space, right? So in those kind of cases, slices could also be important. And lastly, reversing. Some kind of problems will be much easier to work with if you have like a reversed sorted array, so that you go from like the largest item to the smallest item, for example, or vice versa. And you can also do this reversing in place or with like a return like a new array. So knowing the distinction between those 2 is important as well. So I'm just quickly going over them, but if you want to know more details, we have also created appendix for you. So you can click on this appendix link and it will basically jump to the later section of these slides that has more details on it. So highly recommend checking it out during your free time. All right, so we don't have that much time, so I'm going to quickly go over this. But so yeah, for today, like the sample problem that we're going over is called pivot index. So I'm going to kind of give you the problem statement, which is that given an array of integers like nums, we want to write a method that returns the pivot index of this array. And so what is pivot index? So here we define the pivot index as an index where the sum of all numbers to the left of an index is equal to the sum of all the numbers to the right of the index. And if no such index exists, we should return -1. So just to kind of go example here, the nums here, we have an array of 2, 6, 1, 2, 4, 5. It's pretty random, but we want to see if this array actually has a pivot index. And if so, return that pivot index, right? And in this case, like the answer or the pivot index is 3 or the 3rd index. Because you can imagine, hey, if you add the sum of the numbers left of the 3rd index, in which case it's 2, 6, 1. Sorry, I guess this should be 4. Yeah, sorry. So, well, I guess like 4 in terms of like real life counting, but like 3rd index from like a computer science perspective. So yeah, I guess we can just keep calling it this as like a third index. But like if you imagine adding all the numbers to the left of the 3rd index, so the number in the 3rd index is number 2, and the numbers to the left of that is 2, 6, 1. The sum of this is 9, because it's 2 plus 6 plus 1 equal 9. And that equals to the numbers to the right of this pivot index, which is 4 and 5. And 4 plus 5 is equal to 9. So in this case, we know that the pivot index is the third index. And then other example, if you are given this like example array of nums with 1, 2, 3, you know that this one doesn't have a pivot index because with whatever combination you try, there's not going to be an index where that gives you where like the sum of the left, all the left numbers and the sum of the right numbers is going to be equal. So that's the problem. So to kind of follow like the 5-step process, you want to ask questions here, right? So and we can kind of like practice this as a group here. I want to ask you guys, what would be some of the questions that you'll be asking here?
What is only if the length is only 2 or less than or equal to 2?
Yep. Then yeah, you could ask something like that, simple, right? Yeah. What if the length is like 2 or less, right? What do we do? Then you know, if I'm an interviewer now, I could be saying, yeah, if that's the case, you could kind of treat that as an edge case, and you also know that that's not gonna have any pivot index.
Another question is, are
Yep.
all the numbers positive or negative?
Right, that's also a good question. Depending on problems, like having both positives and negative numbers could change things. In this case, you could also expect both positive and negative numbers to show up. So that will be my kind of like answer to that question.
I would ask about how to deal with an empty array.
Okay, empty array. Yep. That would be like another question surrounding like a possible invalid input, right? So for invalid input, it could be returning just like -1 right away. Any other questions?
Then it's always going to be an array, right?
Yep, it's always going to be an array. Yep. So yeah, a lot of good questions around the format of the input and how to handle like some of the invalid ones. So yeah, those are good things. As you kind of get more familiar with it, you might start to realize that, yeah, I mean, oftentimes it's good to just add those invalid input handling. Or like, you might just want to mention it, and then your interviewer might be like, oh yeah, like, okay, we see that you understand that it's important to handle invalid input, but just don't focus that during the short time of your interview, and focus on like the main part of the solution, right? So they might just ask you to just glance over it or skip over it too. But I'll say one important question to ask here is like, okay, what happens if the input contains multiple pivot indexes, right? This is a question that has not been asked before, but it's also kind of important, and that it shapes like the scope of the solution. Because you could be returning the first one with the leftmost pivot index, or you could be asked to like return like all the pivot indexes, which would make this problem a little harder. So you could ask questions like this to start like narrowing down the scope of the solution. And if I'm like, you ask this question, your interviewer might say, oh yeah, in that case, just return like the leftmost pivot index, or like in this one, the first one, essentially. Right. So that's that's going to be the step 1, or asking question step. So good job asking those invalid ones, invalid input questions. Okay, now going to move on to step 2, which is like designing an algorithm. So kind of the first question here that should come to the top of your mind is, what is going to be a brute force solution here? Remember, to kind of get back to the problem here, we basically want to find the pivot index where the sum of the numbers to the left of the index is going to be equal to the sum of all numbers to the right of the index.
So I guess, yeah, the brute force would literally be like, check every index. For every index, check the left and right sum and see if they're equal to each other or not.
Yep, that sounds like a really, yep. Okay, sorry, you were gonna keep saying something?
Oh, sorry. Yeah, and if if you don't, the index, the left and right sum aren't equal, keep iterating through the array.
Does everyone else agree with Eduardo's answer?
Yeah.
All right, getting yes from Horatio, but anyone else? Does anyone else agree or disagree?
I agree as well.
Okay, Nuria, you agree as well? Okay.
Yeah, that sounds like a good answer.
All right. Yeah, so Eduardo, good job on that. And what you described is essentially what's written here. So you basically want to iterate through each index, right? And compute the left sum and the right sum together, and check if the left sum and the right sum equals each other. And if it does, return that index. If not, eventually you want to return -1. Right. Okay, now the question that I want to ask you guys is, what is going to be the time complexity of this algorithm? Remember, time complexity is just a fancy word for runtime. So
Would it be O of n? Because it's a linear, so you're just like looping through it.
okay.
Yeah.
So O of n, because you're looping through it. So yes, you are looping through it. In
I
that
think it's
loop,
O of n squared.
Yeah, because there's another loop inside because you have to loop on both sides. So you have
okay.
one loop going through the array, and then you need loops to add all the ones on the side.
Yeah, to add together all of those numbers, right?
Yeah,
Yep.
it's probably n squared.
Yeah. Okay, so Nuria said it is as simple as O of n. Eduardo and Horatio thinks it's O of n squared. Kind of want to
Okay, so
get, yeah, let's see. I want to hear like different opinions. Gerard, you put that O of n squared in chat. Let's see. All right, so yeah, so actually O of n squared here is the right answer. So Nuria, kind of like the things that you need to remember about is that yes, you need to keep track of like the iterations or like looping through, like just like loop through the array. But you also need to kind of consider the runtime of the operation inside those loops. So in this case, like each of the sum operation could take O of n, because yeah, basically to get the sum of like the left number, you might be doing like like k number, right? In which case the right sum is going to require adding together like m minus k minus 1, right? And which is essentially also n as well, because remember what I said about constant and disregarding the lower term orders. So in this case, the worst case scenario, each sum operation takes O of n, and this is done n times through like each iteration through the loop. So this is why we end up with runtime of O of n squared. Great, Nuria said you got it now. So is anyone else confused by this answer? All right, seems like everyone's good now. So yeah, so now I want to ask you guys, what would be a more efficient solution here?
One that doesn't have a nested loop.
You could get the length of the array and then divide that by 2. And then if it's an integer, that will probably be your index, or well, not your index, but well, I mean, do something like that where you get the length and then you divide by 2, and then yeah, you get that.
Sorry, I have been speaking for like almost an hour, so
Yeah, that makes sense.
starting to cough up here. But so you said, so you want to divide the array by 2, is what you're suggesting?
The length, right?
Yeah, that's what makes sense in my head, but I don't know.
So,
Well, if you divide the length in two, you will start to miss those cases where, like, you could imagine, like maybe the last number is really big, and in order to equal that, you need to sum up all the numbers like leading up to that index to that index prior to that last number, and if those add up together to equal to like the last last like large value, then if you like divide in half, like you're gonna miss that, right?
Could you also run through the array the first time, add up all the numbers, and then a second time when you go and kind of keep subtracting onto left and right kind of equal? And if it doesn't, if you get to the end of the array, you can just return -1. And
Yeah.
otherwise, you can send the index, and that will run in O of n. Well, 2n, but get rid of the 2, so it ends up being O(n).
Yeah, Wilmer, I kind of like where you're going with this. So just to kind of rephrase and clarify your solution, it seems like first thing you want to do is you want to find the sum of all the numbers in the array.
Yeah.
Okay, and then can you kind of like tell us once again, like what you're gonna do with that sum of like all the numbers and what you're gonna do next?
Yeah, so since I have the total, I can just loop through it again, but at each index, I would just subtract the values as I'm going until I get a numbers that's kind of equals to where the numbers that I keep adding up are equals to either half of the total, and then either the index that I get will be the answer if both sides are equal. Otherwise, if I get to the end of the array, I can just return -1.
Yeah, no, I think that's a really good approach. Yeah, just to kind of like, yeah. So Wilmer actually has like a really like right intuition here, and kind of go into kind of explaining why that's correct, like right away. But yeah, so kind of like things that you should start thinking about. There's once you start thinking about if there's like any efficient solution here, is that yeah, you should start thinking about, hey, is there any way to do this with a single pass or loop? That's like many of you guys have done here. And another question that was really helpful here in this question, so Wilmer was able to figure it out, was, is there any relationship between the sum of numbers like left of the pivot index and the sum of numbers like right of the pivot index, right? So in this case, yes, like there was like a special like kind of like relationship between the left sum and the right sum that you could also like relate to the total sums to make it more efficient. So kind of like the crux of this problem is that you need to compute the sum of values to the left and the right of every index. But as you could imagine, this would be a pretty timely operations to calculate sum of basically the left sum, the right sum each time. So what you could do is you could first calculate the total sum, which is the sum of all numbers. And this operation itself takes like O of n. Because you need to like loop through each of those arrays together and add them all up to get the total sums. Yeah, and just like watch out, like if you're using Python, there's an easy way to just call the sum function and get the total sum stack. But don't be fooled into thinking that as a one operation, because underneath the hood is actually, as Wilmer said, it's like iterating to each like number in the array to add them up. So that's still going to be an O of n operation. So once you know the total sum, then you could actually like start kind of like defining this relationship between the left sum and the right sum. So you can imagine that, hey, if you know that the left sum, which is like all the sum of numbers that are left of index I, the other sum to the right of index, which we're going to call it the right sum, would be basically right sum equals the total sum minus left sum minus that value that's pointed by the pivot index, right? This is basically saying the right sum is going to be like the total sum minus like everything on the left minus as well as like the value at the current pivot index, the current index. And if they equal to each other, then that index that we're currently like standing on right now is the pivot index, and we just return that. And if not, we basically move on to the next index and basically kind of like repeat this operation again until we find that's like pivot index, or until we don't find any, and just return -1. And in code or in Python, this is like how you could write it, right? So as Wilmer mentioned, you can first find the total sums. With Python, it's really nice because you can just call it just like sum operation. And then then next step, you would basically start keeping track of the left sum. So you could like declare that as 0 in the beginning. And as you iterate through each element in this like nums array, you basically do this like calculation to see if they match, right? Which is like, you check if left sum is equal to total sum minus left sum minus like x. Let's see. And then, sorry, this should have been, I guess, like, yeah, this is left sum. That's right. Yeah, so that's equal. Then, yeah, then you return I. And if not, you return -1. Yep, it's a pretty smart solution. I definitely agree with that. But yeah, does that make sense to folks? Yep. So kind of, yeah, we're gonna skip over step 3 through 5, but you can imagine step 1, 1, and 2 is like a really important steps in kind of approaching technical questions. So just want to kind of demonstrate how to go about it with this example question. So that's it for today. And then for next lesson, we're gonna kind of pick up the remainder of this array, and we'll also start to dive into this topic with string, which you will see is also related to how you would approach arrays questions. So hopefully this lesson was helpful to you all. Feel free to kind of go over this lesson or start practicing these kind of array problems with your mentors. But yeah, hopefully this was a good lesson to you all. And we'll see you again after 4th of July.
Thank you so much.
Thank you. Have a good day.
Thank
Good
you.
week.
Yeah, have a good one. Oh, and quick, can I ask a quick question? Sorry.
Sure, yeah.
Oh, just real quick. If you have like any, this could be something to go over the mentors too, but if you have like any practice problems or a spot to find some practice problems, that'd also be super helpful.
Yeah, no, that's a good suggestion. And yeah, so now that we started going over like first technical topic, we'll start posting questions in the coding questions channel on Slack. We'll probably post anywhere from like 1 or 2 questions each week for you guys to practice on.
Yeah, that'd be good. And then we can just do them with the mentors.
Yep. And then you can like
good.
yeah, and you can like go over them by yourself, or you can go over them with your mentor, or you can start like feel free to start posting solutions to the reply section, so that others don't see it yet. But the mentors would also start responding to your solution. So
Sounds good. Thank you. Have a good day.
hey, cool.
Thank
See you guys around.
Bye-bye.
Thank you.